Now let's just see the next subtopic under the factorization of the polynomial, which is called as nothing but splitting the middle term. What is the meaning of splitting the middle term? Let us suppose we have a quadratic polynomial ax square plus bx plus of c, and we can write this particular polynomial as in the formation of px plus q into rx plus of x, where both of these are nothing but the factors of this particular quadratic polynomial. So let's just compare all these terms all together, or this whole method all together, because this method will definitely help us to find the factors of the given polynomials. So let us suppose we are comparing both of these, but before comparison let's just expand the right hand side. So as we can see, ax square plus of bx plus of c can be written as, let's just multiply these two brackets all together, so we can get the value as prx square plus of pxs plus of qrx plus of q of s. Now let's just compare both of the terms all together, but before comparison let us suppose I am taking some of the things common. Ax square plus bx plus c can be written as prx square. Let us suppose I am taking x common out of these two terms, so it would be like ps plus of qr of x plus of q of s. Now let's just compare the coefficients of the terms on towards both sides. So let us suppose we are comparing the terms. So compare the coefficients of variable x on both sides, of variable x on both the sides. So when we are comparing the coefficients of the variable x, so let us suppose we are starting with the highest degree, that is x square. So x square and x square, the coefficient in the left hand side is nothing but a, and in the right hand side is nothing but p of r. Now let's just compare the coefficient of the variable x. So we have the coefficient of the variable x as nothing but b over here, and further we have the coefficient of x as ps plus qr. So ps plus of qr. So we are comparing the coefficients of the variable x and x square, even the constants as well. So we are not only comparing the coefficient of the variable x, but we are comparing the coefficients of the variable x for the different degrees as well. So we are comparing the coefficient of x square as well, we are comparing the coefficients of x as well, and we are also comparing the coefficients, or we are comparing the constant terms as well on both the sides. So x square's coefficient is a is equal to p of r, x coefficient is b is equal to ps plus qr formation, and the constant is nothing but c in the left hand side, and in the right hand side it is nothing but q of s. So let us suppose I am calling it as 1, I am calling it as 2, and I am calling it as 3. So from these three equations, what we have deducted, from these three equations we can deduct that b can be expressed as the sum of two terms. As we can see, b can be expressed as the sum of two terms ps and q of r, such that their product is, so let us suppose we are taking the product of these two terms, their product is p of s into q of r. Let us suppose I am rearranging it, we can write it as p of r and q of s. We can see from the equation number 1 and from the equation number 3 that pr can be written as a, so this can be written as a, and qs can be written as c. So this is nothing but AC. So at the end, what we can deduct from these three equations 1, 2, 3, that b can be expressed as the sum of the two terms whose product can be is equal to the product of AC. What is A and C? A is nothing but the coefficient of x square, and C is nothing but the constant term that do exist in this quadratic polynomial. So this is all about splitting the middle term. So let's just do a question in order to apply all these steps in the example. So with the help of the example, we can clarify the things, I guess, more. So let's just see the example.